so you've seen my face already. I'm Leah McEwan. I'm the chemistry library and most of the but I especially wanted to introduce my colleague, Wendy Kozlowski. She's a data curation specialist, and she's also the program coordinator for the Research Data Management Services Group, which is a campus-wide group that includes experts from several different offices, including the library and
Center for Advanced Computing, Central IT, the Institute for Social and Economic Research, and we work very closely with the Office of Sponsored Programs. So it's a campus-wide effort.
So there's a whole diversity of people with data expertise in a lot of different fields with a lot of different functions around data. So it's not just about, but we're going to be speaking mostly probably because we're both librarians coming from the library perspective, things about curation and management support. But I think we do have some stuff at the end, if you need broader support in your data. Oh, that's all right. Take away, Wendy. Oh, it's a session. Okay. Do you want me to just keep going?
Sure.
Okay.
So this talk, Leah and I have built together. There's going to be a lot of back and forth, so be patient as we glance at each other and remember who was supposed to talk on each slide.
Yeah, true scientist action. It's all very last minute. Both Wendy and I have background in our respective fields. We were former recovering scientists.
Never.
Okay, so we've heard data come up a lot today. We heard from Dr. Linder yesterday, sort of at the responsible conduct perspective on data and managing your data and why it's so critical. And I think Martin Teschel mentioned very briefly that, data can be considered a tangible asset. And that top bullet is really, I claim that top bullet, it's really from my perspective, but I think as far as the institution, like a research institution as like Cornell goes, next to producing top-notch researchers, and that's going to be you, we put a lot of the infrastructure really goes into the data that you're collecting while you're doing your research here. That's a really critical function of the university. So we consider them very valuable. It takes a lot of your time to collect them. It's ultimately the contribution to the scientific knowledge in addition to the papers that you publish, and there's a lot of potential for further application. So I just kind of wanted to emphasize data from a value perspective in addition to the responsible conduct that Dr. Linder and also Roald talked about yesterday.
And Leah's last bullet on that slide, if you saw that, mentioning that we're in kind of a data critical area. And I tried to do a little bit of work to see what can we use to illustrate that point. This was an article that was published first in Archive and eventually in one of the librarianship journals. And it was some research that was done looking at a bunch of things. This is a plot of the number, using a definition of the growth of science as the number of papers that are cited in publications that came out. So this is a group in Germany that looked at data out of the Web of Science and plotted the number of citations from papers published from, I think, 1812 to 1980 to 2012. So the citations used in those papers. And they used a regression analysis to try to find out what the doubling time was, trying out if there's breaks in this publication scheme. What you can see here coming out since about the 1940s is this very last area where right now they're thinking that the scientific outputs defined this way are doubling every 9 years. We're in an exponential growth. So if you also say that scientific outputs are going to require data that underlie them, we're generating a massive amount of information right now. There's lots of different ways to explain this, but that's one of them.
The end there goes off, obviously.
Well, if you think about it, because those papers have not yet had time to be cited. So if you were to rerun this analysis, running it closer, like if you were to run it now through 2017, there would still be a drop on the brand new papers because they haven't had time to be cited yet.
Or anything along the lines.
I don't know. I suppose there could be some impact in there, especially as those publishing methods grow.
And again, it's not granular enough probably on this chart to look, but it would be interesting to dive in to that later portion of it.
And probably not the way this analysis was done, because this was using Web of Science, which is looking at not kind of the non-traditional publishing avenues as much. Yeah. So, however, despite the fact that there is all this data out there, we're losing it. This is a study that looked at just over 500 research papers and tried to physically go through and find the data in them. And ultimately what they showed here is the probability of them having a success in 4 different areas. So the first one up the left, the A probability, is, okay, do these papers even have a working email anymore? Drops over time. You're getting down to almost only half of the papers that are 25 years old. For those that have a working email, what is the probability of getting a response? That's pretty consistent. So we seem to keep our working emails if we have them. Probability of actually getting some information, if you get a response from that working email, probability of getting some information is pretty good. People are still willing to talk about their data. However, can we actually get to that data? Is it still in existence somewhere? And that drops severely over time, over just 25 years. Most of the people, many of the researchers here at Cornell have been here 25 years. Not many, I don't actually know what the stats are, but 25 years is not even a full career of your scientific lifetime. And look at this, 25%, almost 25% unavailable after 25 years. So we're not yet doing a good job to take care of our data. So the definition, what they defined here as extant is the data were either shared publicly or the person who they talked to said, I have this data and I could give it to you, but I'm not willing to. So this is the actual data, I have a word in my, is it actually in existence still and findable, is how they defined that. Okay. So just to be clear, what we're talking about when we talk about data management, a lot of people think of data management as something like, I'm going to put my data in a database and so therefore I'm managing it. That is one way to manage your research data, but that's not what we're talking about. When we talk about data management, we talk about a whole suite of activities that are throughout the whole life cycle, from planning to the point of sharing or storing or archiving, that helps you take better care of it. So it doesn't have to do with research methodology or design. It isn't related to data science. It isn't related to the actual analysis, how you do the analysis. It might be related to having really good tools so you keep track of your analysis, but it isn't the analysis itself. So that's what we're talking about when we talk about data management.
I think this gets a little bit at what you were asking before about the publication. We talked about open access publication relative to manuscripts, but definitely digital is impacting data too. So digital data are encoded in machine-readable formats, and so, you know, when we think about that, I think there's a lot of data that's written into our manuscripts, you know, our figures and our tables in our publications, but at that point they've become human-readable. Ro touched on this a little bit. You know, that's not necessarily machine readable. That's not the original way it was pulled off of an instrument. So, in this digital environment, we're definitely dealing with this cross tension between human and machine readable, automated workflows, manual workflows in some fields. I don't know. Certainly, this happens in chemistry, and there'll be a lot of chemistry examples in here because that's my background. But I don't know how many researchers are aware of it, but there's actually a lot of investment of pulling data out of those text block, you know, analog formats, published in papers, and recompiling them in databases so that more people can search across collections of data. And as we see the, you know, kind of digital publishing evolving, you know, it'd be great if more of that data could be ingested, you know, kept in the digital form all the way through and managed all the way through on automated workflows rather than being put into the papers and then extracted back out. So this is definitely a trend that's happening. I know in that field of chemistry, some of these workflows are moving from an analog more over to machine readable. So, you know, bringing this back down to where you are, you know, there's a lot of big talk about big data and changing the, you know, the course of publishing and changing the course of funding. I think, you know, our message for you is really, you know, what works for your workflow. You know, and there's reasons to take care of your data to make your life more efficient. I mean, can you find the data that you took last week when you come back this week? You know, what happened between the break? You know, do you remember what you were doing before you left? Even just your own workflow efficiency, in addition to some of the responsible conduct that we've talked about. I mean, another key issue is some of you work in areas where the data are really secure. And I think Wendy will have a little more to say about that later. So this is definitely for your own good, as well as the good of science. So there's a lot of different, we just were getting a little bit into talking about process data. And Maureen talked about this. She asked us yesterday, what is data? And then we talked about, well, what about the experimental settings? What about the conditions? What about the observations that you take in the course of your experiment? So we just kind of put together this chart to help us think about, you know, in addition to raw data, which is just what we're actually collecting, that there's a lot of different data types, and it's easy to forget some of these, I think. You know, so for example, you know, in the chemistry literature, you'll see a lot of graphical representations, which are really derived, but where's the raw data that supports that information? You know, if you really wanted to look more closely at some of the characterization data, you know, the spectra, you know, you're looking at a graph, and it's hard to get the granularity to actually get down into the XY data that was behind that, and, you know, and analyze it more specifically. So, you know, this is kind of thinking about having all the parts, you know, that there are a lot of parts to the data, and that having some of that context can be kind of critical too, right? If you don't know what the experimental conditions are, you know, how can you make some, you know, kind of some judgment on the data if you're a user coming back and trying to reproduce or do another analysis on it. I think another thing that's kind of come up here, and Roald sort of hinted at this in his talk a little, is there's a lot of people who are doing experimental science. You're actually measuring raw measurements, and then there's a lot of theoretical science that's being done, and these are, you know, people like Roald, who's using a lot of that measurements that are collected by others, not generating his own, and he's recalculating. So you have, you know, in addition to the data generators, you have a data users scenario here. So all of that is part of this landscape. So we're in our own little piece of it, but it's all part of the continuum of data, and it all impacts your workflow, what the policies are going to be in any one field, what the best practices are going to be for you and for your discipline. Any other thoughts about?
Yeah, we wanted to touch a little bit too on the drivers of some of the requirements and the things that we're talking about. In this case, we're talking specifically about data sharing. There's a lot of journals that are requiring this. So some of the big funders are, or some of the big drivers that I see, one of which I think we were talking about yesterday was the ability to create reproducible science, and sharing is a piece of reproducible science. Another one is the funders. They would like to have reproducible work so that they're not made fools of. They want return on their investment. Roald mentioned yesterday the ability to make sure that you actually did good work. Ultimately, I mean, there was a money thing involved, but it was about having good science and proving that you did what you said you did. So that's that reproducibility from the funders and from the publishers. So this is just a very small set of obviously some of the bigger publishers, but this is not uncommon. I give a very similar talk to a group in the economics department, and I just randomly went through and looked at a couple professors at Cornell in the economics department and looked at what journals they're publishing in, went to those journal requirements, and they're requiring data sharing as well. It's pretty universal. It's not heavily practiced yet in the humanities, but we're getting there. It's not uncommon for you to have a requirement or a strong recommendation for a journal to make you share your data when you at the point of publishing. I mentioned funders, so NSF is obviously a big one. So they require data sharing since 1995. That statement that's highlighted in this slide has been there verbatim, unchanged The digital version only goes back to as early as 1995. I started my first work with the NSF in 1994, and I know it was there too in our paper copy. In 2011, they began requiring this thing called a data management plan. How many of you heard of data management plans? A few hands have gone up, but not many. So it isn't just the NSF, a lot of the other really big funders at Cornell, Department of Energy, NIH, USDA, NASA, many, many funders, both public and private, are requiring these data management plans. So I think the next slide to talk a little bit about what I mean by data management planning. So a data management plan is basically your written but living plan for how you're going to handle your data, both during collection and after you're actually done with your research. And basically, it's a process to prove, to show that you've thought about what your options are, what you're going to save, and how you're going to save it. It is meant to be dynamic. All of us have workflows that change. The average PhD at Cornell is 7 years. There is no doubt that you're going to change some of the tools that you use and the way you name your files over those 7 years. But just think logically and carefully about it and try to document it so you remember what you did in the past and what your plan going forward is. So generally, this formal document that you need to submit now with a lot of these funders, the details change slightly even within directorate in NSF, but generally all the funders are looking for this stuff. There are many more details on the RDMSG website. If you would like to, if you end up applying for like a dissertation improvement grant, you're going to have to submit a DMP. You need to do this. They want to know what you're going to generate and what of that will you be sharing. They want to know what file formats you're going to be using and what kind of standards are involved with those. Like, is there a norm in your field? For astronomy, will you be using FITS files to describe your metadata? They want that put in the data management policy. They want to know if you're going to share it and when and for how long. And they want to know if you're going to put any limitations to that sharing. Is your sharing plan to say, if somebody finds my email and it's still working and they actually get me while I'm not on vacation, I'll mail them a disk? Or is your sharing plan to use an open repository? They want you to state it. And if you're using a less open method for sharing, why you're doing it that way. There are some cases when, what is it called, Henrik? A sneaker drive is a reasonable way. It's really the only way realistically as a graduate student you can financially share your data, but you need to explain that.
Sorry.
No, that's okay. And then they want to know if your sharing plan doesn't address long-term access, so that method of sharing it under your desk, that's not going to really archive it once you're dead and gone. How are you going to address that? And then they want to know who will be taking care of this kind of stuff. So very high level, but that's the kind of stuff you're going to need to think about if you ever have to write a data. So why would you do it? Again, this is about you and your workflow. Ultimately, hopefully it will help you. It will save you time in the long run. So you, at the point where you are saying, all right, I've got to start this experiment tomorrow. Oh, I've already thought about my file naming practices. It's going to save you some time there. It will make you more efficient, and it'll prevent duplication. You won't have to rethink how you're doing things when you get to the point in the experiment where you're actually keeping it, doing the actual activity. Definitely helps keep you a little bit organized, tries to keep you consistent. When I write things down, I know that I do a better job of actually carrying them out. And this idea of information entropy, I have another plot that I didn't include here, how actually our memories, how quickly our memories decline over time. And I can speak for this myself. I actually took 5 years to get my master's degree. And I know that I couldn't remember at the beginning of what I did at the beginning at the point where I graduated. So many iterations of my work. And documenting it and writing down what I did really helped me. So, and basically, if you think, oh, I'm never going to apply for a grant, I don't have to write a DMP, I recommend you think about these kind of things, even if you don't have to. Having a plan and thinking at least about how you're going to organize your content ahead of time is really going to help. All right, I apologize for this slide. Lots and lots of words. Look first just at the column in bold. That first thing where we said that they wanted you to think about what data you have and how you're going to keep it safe. There's lots of options at Cornell for where you're actually going to store your data. Lots of ways and things for you to consider. One of the prime ones is thinking about the classification of your data. Okay, so this is starting to get into some of the kind of more hands-on things we're going to talk about. So these are the major classifications you're going to see. Cornell isn't, I will admit, particularly consistent in their wording. So be patient when you look through things, but look more at the concepts here. So public data is really stuff that's out there and available for anyone to use. It's not behind, I mean, it's you could do a Google search and you're going to find it on the web. This is usually post-publication data. Almost all the research data at Cornell is considered sensitive or moderate risk. That means it doesn't have any official confidential information contained in it, but you really don't want people to find it, right? It's your research and you don't want it to get out there for anybody else to do what they need. So most data is considered sensitive, and there's lots of different options for sensitive data at Cornell. How many of you use Box? All right. Dropbox? Okay. That's awesome. Google Drive. Okay. So those are all possibilities. I'm gonna talk in the next slide a little bit about better and worse and things to consider. We're moving up the level of here. The next level will be confidential or restricted. But we can high risk Cornell. There's places for you to store that kind of data. How many people officially have confidential data? Much of it is the social sciences. Export controlled information is a subset of confidential that actually has even higher restrictions on it, as well as HIPAA regulated. Again, here on the Ithaca campus, there's almost no HIPAA related. We don't do medical work. Most of Cornell's HIPAA data is down in Ithaca. But there's options for you in each of these. You can come back and look at this later if you would like. There is a tool on the RDMSG website, the Data Storage Finder. The URL is up there. There's a handout on this front table about it. I mentioned that data classification is one of the things you can think about. And this is a interactive tool on the website where you can pick what type of data you have and all the different data storage options, regardless of who provides them, right? So some of these things are provided by central IT. Some of these are provided by the library or CAC or Sizer. What we've done is we've talked to all the product owners and pulled all the information into one place. There are 6 questions. So in addition to data classification, there's other things for you to think about. How much data do you have? Who do you have to share it with? How secure do you need it to be as far as backups and replications? Those kind of questions. As you answer those questions on the left-hand side of this tool, your options change on the right-hand side to what fits those requirements. And then if you select individual ones to learn more about, the next page then shows you a comparison chart, including things like how much it costs and how easy it is to use and those kind of things. So a really good way to find options for you. I think the next thing is best practices. So getting back to that idea of what tools you actually use and how you consider them. Don't think I actually put it on this slide. One thing is here, when you're choosing the tool, consider the security behind it. So when Leah said, oh, not so good, when those of you who lifted up your hands for Dropbox, that's primarily not because Dropbox in and of itself is a bad tool, but it is not a tool that is yet sanctioned by the university here at Cornell. So it has not, their security practices have just not been vetted by the university. So we don't know where their servers are. They have the right, Cornell has no contract with them, so they have the right to do whatever they want with your data. And you have no protections offered to you by the university's legal counsel should something happen to your information. That's
same with Google. It's the same with Google too.
Actually,
Google
we now have a contract with Google.
Oh, okay.
Yes, that is very recent. Drive now falls into the good category because Cornell has a contract with it. So Box and Google are much better options for you than Dropbox, even though I realize Dropbox can be really handy.
Is there discussions ongoing with Dropbox? Is that something you expect to change, or?
Like we've done with Google.
Like we did
that
with
was
Google.
A concern for a while with Google
because people were using it anyway.
I'm
I'm not privy to those conversations. I know that people even in IT like using Dropbox. I would be surprised financially if the institution took on another large storage better because we already have Microsoft OneDrive, Box, and Google Drive. So it's a possibility, but I would be kind of surprised if we took on another. Henrik?
Personal Google accounts and personal the university not stand
Correct, and there are very easy to understand instructions on Central IT's page. If you go to the Google Suite for Research, if you look at that on Central IT's page, it will tell you how to create your Cornell account on Google and then link all your personal content in through your Cornell access. So you do have to access it using your net ID. Yep. Okay, more generally speaking though, data storage. How many of you keep 3 copies of things? Ooh, I see a few hands. Okay, general recommendation is at least 2, best practice is 3 copies. Most of us keep a copy locally, right? I see lots of laptops out here. Really good practice, especially if you're doing any kind of traveling or field work, is 1 external copy, a good old external hard drive, flash drive, something that you can physically have in a different place than your laptop. So when you're traveling with that extra copy, don't put both your laptop and your external drive in the same backpack.
This has happened.
It has happened. 3rd copy, somewhere on the cloud, something like Drive or Box, or worse than nothing at all, or better than nothing at all would be Dropbox. But do keep in mind, especially when you're using these cloud products, I myself set up sync to my laptop, right? So I don't necessarily have to go through my browser. How many of you use syncing on your computers? There's a few of you. Syncing is not the same as the point where I talk about here where you want to keep backups of all this stuff. If you make a change on a file that's synced, it goes back and changes it on a copy of it. So it doesn't let you recover any mistakes that you make. You delete a file accidentally and those drives are synced, you're going to lose them in both places. So don't get confused thinking that you have, oh, I have a backup copy because I sync onto my local machine. That's not the same thing. You may be working, oh, sorry.
Yeah, when you say like keep 3 separate copies, are you trying to like against like this failure or like one of them getting lost? Like for example, the research group I work with has like their own like data storage thing. It's like private, and I assume it's free, right? Is that 3 separate copies? They're all the same in one physical. They're all in one physical location. That's just 1 copy.
So if they're all in one location, that is not well. It is multiple copies, and that prevents against drive failure. But what it doesn't prevent is a fire in your building and a sprinkler going off, and all 3 of them getting lost.
Flooding happens too.
Yeah. So yeah, I probably should have put up here too what I usually do on this slide. So at least one of these needs to be geographically isolated. So usually your cloud copy covers you for that. And often if you're using these automated systems, a lot of the departments here at Cornell use a product called Easy Backup, which goes in and automatically creates backups of content on your personal computers.
Servers management,
yep.
CIT, right?
Yep,
So
and those would be a geographically isolated. You may not be able to back up everything. It may be too expensive, so consider what it is that you need to back up. And don't just assume that they're happening. Make sure every once in a while, go in and test, because the only time you're going to actually need your backup, I can guarantee you, it's going to be right before a presentation or a talk or a conference, and you're not going to have time to mess up or mess around with figuring out how to get it or if it's even happening at all. Things like Dropbox, know how often or how long they keep copies of things. So Dropbox right now, by default, only keeps things for 30 days, regardless of when you've made a change to it. So you make a change on day 1, you move to a different part of your project, you can't access those old versions of things on Dropbox. Those settings can be changed, but go in and look. Make sure you understand what kind of things are going on with your backups. Know how to restore it. Sometimes you can put stuff into an archive instead of a backup, something that might be, if you're working with really large volumes of data, something you don't have to access as often. And make sure you've written down your plan so that if something should happen to you, the rest of your research group knows that what you're doing with your storage and your backup. All right.
That's data storage. Now on to
Yeah.
major area number 2.
So we thought we'd talk a little bit about research record keeping, and maybe we'll just put all 3 of these dots up here because we probably don't have time to go through, but this is kind of a fun exercise. If you think about these 3 different scenarios of what would you do if you were trying to locate, this is an example Leah already mentioned, some work that you did for 6 months ago. How many of you think you'd be able to find work that you did 6 months ago? Within a short amount of time. Okay, quite a few hands. All right, let's go back to that fire scenario. How about if all of the contents in your physical lab space were destroyed? How many of you would still be able to get to your data?
We have had explosions in this building.
A lot fewer hands that time. Okay, how about if you yourself are lost? Would somebody else be able to get to the work that you're doing? So 3 different things to think about. Okay, I see one hand up there. All right, so the best practice is I put that up there because instead of fitting it all on one slide, we had to break them out. Henry.
When you consider system manager,
So that's the first piece of it, right? Actually physically getting to the stuff, right? Knowing where it is and being able to get to it. But the larger piece is being able to continue your work. Would they be able to understand and actually get through your content and pick out what it is that you were doing? Would they understand your organizational structure and your file naming? Would they be able to find your notes and pick up where you left off? So there's kind of 2 pieces of it.
And actually, really, I mean, your PI has that right to understand where your work is at any moment. And I know that this is one of the actually primary drivers for some of the labs I work with about moving into like an electronic notebook. It's partly about the backup, but it's also about the PI being able to have a better sense of what people are doing. So yeah, someone's watching you. Do you want to jump into these things?
Yeah. So looking at things like being able to understand what you did, file naming. How many of you feel like you have a consistent practice that you use for file naming? Shy here. Oh, let me do it the other way. How many of you feel that you don't use a consistent file naming structure? Okay. I would highly recommend, especially if you're early in your time here, that you think about a consistent way to name your files. Getting back again to that time-saving, practical practice of what this can do for you. Using good file naming practices can make a world of difference for you and for anybody else who needs to work with your content. So you want to be able to you should use descriptive file names. This is more in the human readable than the machine readable aspect of things. You want your names to be machine readable, obviously, but really ultimately we all need to be able to identify our content, right? Do not use special characters. Do not use spaces in your file names. There's a lot of our user-friendly systems. I see a lot of Macs out there that handle file or spaces in your file names. But as soon as you take it out of that system somewhere else, which you don't know what you're going to need to do 5 years down the road with your data, spaces are classic for messing things up. Spaces and special characters, especially multiple periods. I know Mac OS can handle those, but don't do it in your file naming structures. So no special characters. Try to avoid really long file names. There's a lot of ways that this really messes things up.
Probably too long.
This example is pretty long. Yep, we should have used our initials.
This is the name of this presentation, by the way.
Yeah.
That we used.
Yeah, the folder. So it gives us an idea of when we did it. This had to do with the immersion program. It was about research data management. Here's the authors. My file naming structure always uses a single author, and if there's more than one author, I do an et al. Instead of both names.
My net ID there.
Another way to do it. And then some sort of indication of date or version management. So these products that we talked about with you already, like Box and Google Drive, do some version control for you. But like I mentioned, not all of it, you don't have access to everything. Even with Box, you only have access to the 100 most recent versions of things. If any of you use the live editing feature on Box, you know that you can create 100 versions of something in a day. So you may still have to incorporate some sort of version management system, even in your file naming structure. So some major version revision, minor revision in your file.
Can I ask you, can you go back? I want to ask a question about the date. I like this, but the date messes me up because there's no separators between the month and the day. Is there another suggestion, like can we use the underscore or something?
So
We can't use a
hyphens are acceptable. So it was a change in best practice actually fairly recently, where systems there was a analysis done. Systems can handle dashes; they're not considered a special character. My recommendation is to use them consistently, and the reason systems started handling them is because of URLs. So it was really hard in a URL to tell when there was a space because they automatically show up hyperlinked with an underline, right? So you can't tell if when you're typing that in, it was supposed to be a space or an underline. The ISNI standard for dates have two formats, one without the dashes and one with the dashes. The dashes are fine.
I'm old school. This is
No, I don't use the dashes either. Well, I'm gonna do a mix. I must be in transition right now. Okay. Yeah.
About last slide, and there is at the beginning there has a event. Could you please explain what is event?
Yeah, and actually let's do that on the next slide. So this concept is how do you think about your work? None of these organization schemes that we're talking about, there's no one right way. People do come to me and say, how should I organize my stuff? Well, how do you think about your stuff? Right? So for Leah and I, our solution was this has to do with these 2 days worth of work. So it was important for us to associate it with this project, which we're calling the immersion project. But for you, it might be,
sorry, keep going back and forth.
yeah, it might be that your thing is what's most important to you is that it's a subject. It might be that the most important thing for you is the actual type of content. That field just is supposed to suggest that if that is something that's important to you, encompass some sort of project or subject, anything that helps you think about it. But if that doesn't help you, if, for example, we have a friend that works 100% on date, everything she thinks about is when she did it. So everything is organized at the front of her file naming and her folder structure based on date, because that's all she cares about, but that's how her brain thinks. I know I did this in 2008. And once I know the year, I can then go and find my project based on it. And so the way you think should influence both your folder structure and your file naming structure, because then you can organize it. Now searching obviously is going to help you with all of these things, but the fact is most of us do spend some time actually looking at our file manager programs and looking for the file itself, right? We don't search for everything. So having a logical naming structure based on how you think, so that when you order it, you can find the contents. So there's no one right way. Some people just force an order. They're like, I want this file to show up on top. My husband does it. It drives me crazy. He starts everything with a period. Everything against all my best practices. My husband doesn't follow our file. So find a method that works for you and just stick with it as much as you can and write it down. The last few things about kind of high level of keeping good records and organizing your content. One other really good thing to keep track of, depending on what field you're in, is who touched things when and with what. There's a lot of programs that keep track of this for us. Box keeps a record of who makes changes. A lot of the electronic lab notebooks have provenance records associated with them. Depending on your work, this may be important and you may need to build this into your file naming structure. Do keep track of what software you're using. Again, over the 7 years of your time here working on a PhD, it's very likely that whatever software you're working on is going to come out with a new version, and you will be shocked at the differences that you don't know until 2 years later, and you need to know which versions of stuff you're working with. It was something happened, something changed in your software, or in your results, is because your software changed. You keep track of versions. Again, methodology. What you do should also be influenced by those you work with, both in your lab. Your PA may have a very strict structure. There's some PIs, especially in the chemistry department, that are like, this is how you're going to do stuff. And so you don't really have a choice. But this is really important. Think too about collaborators outside of Cornell and what they do. And there's lots of tools out there to help you do it. Some of the things to think about are cost, and whether it's open source or not, what's important to you, what features you must have in order to have the tool work, and think about getting your content out. How easy and how practical is it to move your stuff from one tool to another? So next, I think we're going to talk about a few tools, right?
I don't know if it's probably can't really read this. It's just a fun little, I was doing a study with a colleague in 2014 about chemists using, their file management system. So this is probably pretty typical of us. Many of us have lots of folders and files, but wouldn't it be nice if we had a more systematic way to manage these all together in a system? And so that's kind of how we've gotten into the whole notebook scenario. So I don't know, Wendy, if you wanted to.
Yeah, we can go this real fast. I mean, obviously, you know what a lab notebook is. These are actual images of my old notebooks. You can
those are
see
yours. I didn't know
this
that.
this is me actually taping in an Excel sheet printout to my lab notebooks. That's what we did in the 90s. And I had many of them. We've moved now in many cases to an electronic version of this, but not exclusively. When we talk about electronic lab notebooks, there's lots and lots of products out there. These are ones that actually sell themselves as an electronic lab notebook. But there are others that keep your content in an electronic format that aren't really ELNs, but you can make work for you. Things like
Evernote or OneNote to do all of your actual note taking officially.
Mm-hmm. And then you can actually
fine print. Those also have fine print on them, just like Dropbox does in terms of your rights. So just keep that in mind. Also, those are your official notebooks. And I think another issue that we've been trying to, I haven't looked at this in a while, but several years ago we were having trouble getting data out of Evernote. I think that's probably better now. You can export.
I tried it in a while.
Look into it, but just thinking about these kinds of issues, it works well now for your workflow. That's great, but in the future you might need to be able to get your stuff out.
I think in the last corner is going to show up a couple other tools. So these are really file management systems. But Leah is going to give an example here in a second of how these can be used as a means for recording your digital information.
So not all computers and labs have internet access. This isn't exactly possible. So what would you recommend as the best way for using those computers, those tools?
That's a really good question. So it really depends on the finances you have available. To locally install some of these things has an added cost. Most of these products have local installations that you could put on, but I think that would be a conversation you would need to have with the lab manager to find out whether or not that's something that's feasible. Many of the labs then take the content that can go on the internet off of those computers and put them in a system elsewhere. I know like the CCMR people, they actually move things physically to a system that can then be shared, and some of it goes into record keeping there. It would probably have to be a consultation that we would have to use to see why you don't have those on the internet and what can accommodate those things.
And what your workflow is to then move it off of that, because that's that's a backup issue right there, not having a distributed copy. It might be worth mentioning here that some of these notebooks are coming out of the the industrial sector, where they've been having electronic notebook practices in some fields for decades, but they are usually enterprise in-house systems. It's morphing over to the academic environment. Every lab has a different culture. It doesn't really, while we do have a corporate account to lab archives here, it's not a one-size-fits-all situation. And, Cornell doesn't policy everyone's lab practices like they might in an industry. So most of the lab notebooks that are becoming available, I think, in the academic sector, for the pricing that's probably reasonably affordable for us, are going to be cloud-based solutions. So it's a really good point. We wouldn't really be able to afford, most labs wouldn't really be able to afford an enterprise install, probably. I'm going to guess. At least that's been the experience we've had so far. I just wanted to point out at the URL at the bottom there, datamanagement.hms.harvard.edu/electronic-lab. notebooks. These slides will be available. This is a chart that the Health Sciences Library at Harvard maintains. It reviews a lot of features of a lot of different electronic lab notebooks out there. So if you are looking into electronic notebooks, I think there's a lot of great things. It doesn't get into maybe some more discipline-specific scenarios that you might be interested in, like, can you draw molecules? And this always comes up in chemistry, for example. But it has a lot of really great information about some of the storage issues we've talked about, the documentation, the ability to move data in and out, things like that. So this is a great tool for anyone who wants to look more at their options. Another thing, you alluded to this earlier, Wendy, but this is definitely a conversation you have to have with your PI while you're here. Your work is part of their research program, and so this needs to be something that you and your PI are on the same page with about where your notes are and where your data are. Definitely there's very different cultures in different labs about the comfort level of working with these systems for various reasons.
Leah mentioned Lab Archives, so this is a product that the institution has an enterprise license to. We won't get into it here. We do consultations. I help support this product, so if you write to the RDMSG address or go to that, it'll eventually get you to Lab Archives. If you need help with this tool as an option, as an electronic lab notebook, we can help you get it set up.
Here's a discipline-specific example. I wanted to shoot this up there. So this is MBook. We have one laboratory who is using this product here at Cornell, and they have some collaborators at Columbia, for example. So this is running at both institutions. Well, it's cloud-based, basically. But I wanted to point it out because this is a discipline, synthetic chemistry. We're having the context of the experiment right in with the data is really critical in this. So in this case, this is a pre-scripted template within the lab notebook, and that was entirely critical for them to have their workflow in this notebook. It wasn't just a matter of having a file management system where they could load in, their experimental conditions and their observations and their raw data files or something like that. They needed to have this template, and what this allows them to do is they do many iterations on these experiments, and they can just duplicate them, and all of that documentation is kept track of. We're working with this ELN provider now. They actually already also host a lot of the analysis software that works on that raw data, so there's a direct connection into that software suite. And then we're working on a little kind of publish your data button that will be up at the top bar somewhere, that will help package all of that data together, because they're required to submit some of these analyses as part of their manuscripts when they publish on their research. So it's just kind of, it gives you another example. So Lab Archives is much more of a general platform, where you have a lot more control over your template, but it might not have some discipline-specific features. So I just thought I'd throw that out there. This is probably one of the most structured disciplines that I'm aware of. Any synthetic chemists here? I've already talked to most of them. Right.
So one other thing before you get to that, just because we're kind of short on time, there is another handout on the front table that compares Lab Archives and another platform called the Open Science Framework, which is officially an electronic lab notebook, but it's another online product that's really great for keeping track of your research, and Cornell has an enterprise license to it. And some details about that are on the handout.
So I just wanted to also put this is another chemistry lab, actually, that's used Box. Again, they've leveraged a file management system, but they were really, basically, I think the thing that makes this really work is that it's run by the PI and a staff scientist who manages this whole file structure. And the way she's got this set up is there's some resources that are available for everyone, and then there's a lot of folders that have restrictions on who can see it. And then there's that just kind of gives you that top level. And then underneath each one, having a fairly consistent structure, but with some flexibility for individual students about how they organize their papers. So you can be fairly structured across a whole laboratory about how you use a more general tool like Box. And the great thing on the one hand is, they're not losing any files now, which is great. And they did have a fraud issue in this laboratory at some point. So versioning has become very important, and they have a whole system for managing the 100 versions. And you can see some of the file naming that's evolving. The practices of all of the students in this laboratory are definitely improving on that front. On the other hand, it does take a lot of work by the staff scientist, because she basically is managing all those things that maybe a more specific notebook setup would be. So I threw this up here as sort of a twofold thing. It's great because now they have everything about their laboratory. The PI can see this from wherever he is in the world. He travels a lot. He wants to know what, he likes to go in, see how everyone's doing, leave little comments. Right? But on the other hand, it is a lot of work. But it's always a lot of work to keep track of your notebooks. So it doesn't necessarily make it always easier. I guess is the.
We can skip over this. Yep. Basically, PIs, researchers think data sharing is important, but very few people think they do a very good job of it. But it is effective. Sharing your data has been proven to increase your citation rates. And we were curious, how many of you have had the experience thus far in your careers of getting to the point where you need to share your data for a publication reason or because of funder requirement? See one hand in the back? 2, 3, just a few people. So this is stuff that you will eventually have to do.
Absolutely. Yeah, I don't know if we want to.
Yeah. A lot of people have concerns about sharing. There's this list for, like you said, we're going to share these slides. If any of these ideas or concerns resonate with you, they all can be addressed by having good metadata. How many of you people know what metadata are? Do you know what metadata is? How many of you feel that you create good metadata to describe your research? Henrik! Good job. There's another hand up there.
Decades of experience.
So the key thing really is to realize, it's to think of metadata not as an afterthought, not as something that you do later on when you have to submit your files to a repository. Create your metadata, describe what you're doing alongside your work if you hit it one more time. Metadata is part of your data. Don't think of it as something separate. I offer a full 1.5-hour workshop just introducing you to metadata basics. We decided not to cover it here because it was way too much. But again, metadata can address each of these concerns that people often have with sharing data.
I think I'm just going to put this up here. So all that record keeping, file management stuff we were already talking about, is that how you're building your metadata over the time that you're doing your research, so that when you get to the point where you're sharing your data, or I would also say that most of us are actually already published data as part of our manuscripts. And as I was saying earlier, I'm definitely seeing in some disciplines where that manual work process is going into a digital process, and you will now also be required to include your files, not just in-text data. So this will hit all of us. So there's only 2 hands here that shared data, but actually probably all of us are doing this in some form, and it will hit us more. So these are basically some specific types of metadata, as well as some specific forms of metadata that come into play when you've actually put that data out in the world, and it needs to be used by someone else. But it's all relating to pretty much practices that you are probably doing with your own data in-house anyway. Probably the thing to emphasize here the most, just because we really are short on time, is the identifiers, right? So DOIs, there are DOIs for articles. The whole kind of interconnected internet of articles is pretty much running on a DOI to link all those articles. There are also data DOIs that are minted for data. And depending on which organization you use to mint those, you or the publisher use to mint those data, there's a lot of metadata underneath those DOIs where you can include links to the article to go with the data set, information about you. ORCIDs came up yesterday. I can't emphasize this enough. This keeps you connected to your stuff so people can find you. You do want to not only get counts for but you want people to be able to trace back to you. And then I put chemistry up here because almost everything about chemistry is indexed by the molecules that were studied. And we have an identifier, and then actually that identifier runs most of the chemistry searching and data engines behind the scenes. So including those will make sure that the work on your molecule is findable and connected in. So for chemistry, for example, and there are similar identifiers in other domains. Anything else you wanted to highlight on this side? Anybody have questions about identifiers? Your main responsibility here is to get your ORCID profile set up and do that earliest possible so that it stays with you and all of your work stays with you. People can identify who you are. Oops, put something here on the screen. It's not my computer. I don't know how much. How many more slides do you have? More than we have time for, but again, so this is a screenshot. I'm not expecting you to find print here. We did this analysis in chemistry. The green ones, these are different types of data across the top that are often reported in different chemistry subdisciplines. And we did this color coding thing. All the green ones are already required in a digital format in a repository, and that's crystal data. Probably some of you are familiar with that. There are a lot of other data types that are reported in that manuscript or SI that I was mentioning, but it is in that manual form, and there's definitely some effort to move that. So I just kind of wanted to emphasize that there are already data requirements in the foiled. Here's a crystallographic workflow. You can see in crystallography the instrument and the file format and the researcher, are already connected right into the repository. So in some domains, there's a whole workflow around getting your data out there that goes along with your manuscript. Not all domains and not all data types obviously have it this worked out. So you may also want a general repository option. And we talked about some of this. I'm going to skip all the next slides. Here's
Speaking
one.
of general repository, this is one that's offered by the library. Again, if you want help with it, grab one of those RDMSG cards. There are people that can help you get content in. It's free to all Cornell users. Very general, very generic, not subject specific, but is available as a means for you to share your data.
And it is, there's a sustainability plan around it, to Oya's point earlier. And since it's local to Cornell and we care about everything that's done by someone who's at Cornell, right? This is kind of a nice, sort of ongoing preservation option behind wherever else your data may be posted. On the other hand, it may be harder for your colleagues to discover it because it's not discipline specific.
It is fully indexed by Google. So if you're doing the vast majority of us do, and you look for something on some of the major browsers, you would be able to find it that way. Yep. I think the next slide is just more about the RDMSG and the kind of things that this group can help you do. Again, handouts on the counter up here. I think that's our last slide. We missed the fair use.
So we had a bunch of slides on data reuse, and basically the point there is that more and more data is being ingested into artificial intelligence, machine learning, and this is partly why, and other automated workflows, so this is partly why having digital and machine readable data is useful, and then there's some guidance around that. That's the extra slides.
Are there any questions for our speakers?
Whirlwind. Yes, sir.
Once you leave Cornell, you're no longer affiliated, but you have your data unboxed with the Cornell account. Can you talk about what you do below that?
Yeah.
Accessing your data.
That's a really good consideration when you choose your storage platform. You will lose access via your net ID to most of the tools at Cornell. But Cornell, especially with ones that are supported by the institution, will help you move that over into a private account.
And then the other option, of course, is to pull it off
And move it to something else entirely.
Right.
Yep.
Many institutions have box. So if you're going to another institution, that's something to think about, actually, when you're in that transition phase. What are the tools they have there? Because you may be able to do a smoother transition.
There's a system called the Internet 2 that many academic institutions, at least in the United States, are members of. And there's tools that are approved, internet tool approved, and Box is one of those. If you choose an internet tool approved tool, it's likely to be at another institution.
Academic institution. Another question over here.
When you try to,
Go ahead, sorry.
when you try to design like a good system for like storing metadata, how do you account for things you kind of thought of? Yeah, like 8 feet under ambient atmosphere for 3 months, and then you're like, oh, I want to control the atmosphere. I considered like writing a script to go back and modify those original data files, but I never feel good about doing that because I'm making a safe script.
Yeah. Back up, first of all, make an extra copy.
That is the #1 recommendation that I am shocked that people don't do, is create an archive copy of your data that you don't touch.
Which for exactly that reason. At the time that you made it, this is the way it was made. But then, you know, absolutely, you may want to go back and add, especially that metadata. You know. And so another option too is, you know, this, a lot of it's in the header, and that's with the original. But you could also put additional README files and wrappers on it for extra stuff, and then date stamp your new comments. You know, I'm retrospecting based on my notes that this was done. It allows you to remember why you added that later comment and when you added that later comment. So you can, but it's not in the same file, I think, probably. Yeah.
Version.
There's one more question I wanted to take. DMP.
So if you like encounter some offshoot like experiments or factories, it was not the plan. So is it that you submit a new proposal, or is it that just like they just submit that modification, like appended to the data?
So if this is like an official data management plan that is associated with a funded grant, a project, you are supposed to, in your annual reports for that project, then update your data management plan. Now, at least the NSF doesn't police that at all. So the idea of it being a living document really is about being your living document. So you would append that. In theory, you would need to report the change. There is support I forgot to mention. So one of the services that the RDMSG does is free consultations and will help you write a data management plan. So if any of you have to do that, we can help you prepare those documents. One more.
Oh yeah, I have maybe a little specific question, but like I saw some of the that were still in school and like pen and paper notebooks. I get sick of screens, you know, it's a little more free form, whatever. Do you have a recommended way of like digitizing that in the sense of like I want it to be electronically available for 12 weeks?
Depends on your handwriting quality.
I can scan mine, you know, look at the
So,
read it, but other people still
so you can do optical character recognition on scanned content.
Including handwriting.
Handwriting. Yep. There are also some tools out there that are interactive pen notebooks. I think there's 2 or 3 out there. I have to look up the names of them again. If you wanted to convert to something like that, it actually, using a specific pen and a type of paper, would digitize without having to.
Yeah, Evernote actually has a feature like that, the Evernote app, for example. One thing in additional to the actual content, like scanning your pages or whatever, is to keep a data dictionary or a metadata schema file that's actually your notebook organization, you know, in there, because then you have just a schema of all the pages and experiments and how he numbers your pages. It's almost like a table of contents kind of scenario, you know, text-based file that's searchable. You know, and keep that, you know, in a box or something like that, and tagged, and that way you're searchable, even if the content is still lost. All right. All right, thanks so much.